So, a little bit of background about myself. So, I lead the quality engineering team at Imply. I come from Splunk, and my role at Imply is to establish quality org with establishing quality standards and processes, and ensure that the products that we ship is of high quality and it just works. I'm here also to build and scale the team for the quality engineering organization, and I have some amazing engineers on my team. You'll be meeting one of them today. That's Andy. So let's get started. I just want to touch upon some of the testing challenges that we have with testing open source Druid, right? As we all know, that's a constant worry, like especially with tests. Do we have enough tests? Is the coverage good enough? Is good enough actually good enough? Now, since and especially for an open source project, testing is mostly free form. Yes, with respect to Druid, we do have some well defined unit test coverage. There is a threshold and so forth, so on. There's a decent coverage of actually unit tests. We define some threshold, and we have Jacobo reports that actually give the kind of test that we cover. But what about enforcements on integration test, right? It's like when this new piece of code actually interacts with the other parts of the existing system, we are not sure what breaks, right? So that's kind of still a gray area that we have challenges with, right? And I'm going to talk about how we handle that in the next few slides, right? Other parts of testing are flavors of testing. Like not much attention is given to scale tests or load tests, from an open source testing perspective. So when a developer merges the code, the PR, right? Not much attention is given to that. Those kinds of tests. Browser compatibility is one, and above all, security, right? Security flaws. Uh, that's something that not much care is taken care of, right? When we do the open source testing. So, what is something that we have done, at Imply? So first off, when we have an open source PR, we have an automated GitHub flow every 2 hours that kind of actually brings in that code from the open source into the Druid uh, base. So ideally, the Druid master branch is kept up to date with the Apache master branch. Then, since because the implied Druid team might not have reviewed or been involved with merging of every commit that goes into the open source, we maintain a curated monthly release branch. And this kind of gives us, the team here, a good control on what set of changes go into the monthly release. So that is the kind of gating that we do. Some of the improvements that we have done is, apart from the automated GitHub flow, there are some enforced gates. Some of them are manual, some of them are automated. Of course, the vision is to completely automate these gates. And also, one other thing that we've done is to port all the tests from Travis, which is the open source CI/CD platform, to Jenkins. Uh, the next one I want to talk about is the quality gates. Yes, we have the open source commits coming in. Like, so what is the role of the quality team in all this, right? So, as part of our release process, we have a monthly release cadence, and as part of the release process, the QA team shepherds all the PRs from the open source software, specifically for two things, right? The coverage of unit tests and the coverage on integration tests. So if there is no integration tests, the tests are added before actually putting it into the release. And because this is a risk assessment that we have to do, it's not only about quality bar being high, but there should be some amount of basic quality thresholds that need to be met. Otherwise, we cannot just put the raw code in there and then ship it to our customers, right? So there are some gates there that we enforce for the integration test to be present. If not present, our engineers internally kind of write it and edit part of it, and then we make it part of our automated pipelines, right? So in this way, the open source PRs are pretty much gated with respect to the test coverage to ensure that the quality is high and code kind of gets merged to Druid branches in a very streamlined process, right? Apart from this, some of the tests that we do is we do have some amount of scale tests or load tests, because Druid is all about the subsequent queries, and we need to, the speed is of essence here, right? And browser compatibility test is one. And also we are working towards a data-driven approach. So when I say data-driven approach, it's not about testing a function or a call or an API. It's about testing the kind of data that you feed into the system. And this is very crucial, especially for Druid, because we have customers from different domains, with different background, and their test specs vary, right? So there is a whole suite of tests that need to focus on the kind of data that you're actually testing. Apart from that, also we establish some performance metrics and baselines and so forth. Uh, so we talked about challenges and we talked about what we do to improvise at Imply. What are the quality gates? Yes, but we don't stop here, right? What lies in the roadmap? So, as part of the vision from the quality team's perspective, some of the things that we're trying to lay out or in plans are to shift left, right? I'm sure most of you in the quality industry would have heard this term. It's a term that gets popped up, and then it's you've heard it. That's all I'm trying to say. But executing that is really is a marathon effort, and that's something that we really want to bring about, which means shift left is front loading most of your tests. These include not only unit and integration tests, but even some amount of security testing early on in the cycle to find defects earlier. So basically quality is more of a before thought rather than an afterthought, right? And adding more automation gates. The next part is increasing the code coverage, establishing some standards with respect to not only unit tests but integration tests with for code coverage, and defining some thresholds and standards there. Like your PR cannot be merged unless there is, like, say, X percentage of a threshold on the code coverage, right? And some bare minimum browser compatibility test. In addition, there is also an initiative to kind of reach out to customers to sort of get some idea of the kind of data. It's not exactly that we use their own data due to security reasons. We cannot do that. But something very similar in terms of the shape of data, the kind of metadata about the data itself, right? So what they use, so we can bring that in house and create a customer centric use case workflows, right? That's one. And above all, a very grand vision is that that my team and I are really hoping we get support from the community is to move away from Travis and kind of advocate Jenkins as the CI/CD, because it comes with its own advantage. I mean, this session is not about Travis and Jenkins, but I'm happy to answer questions on that. So if we can move away from it and have Jenkins as a CI/CD platform, that'll be a good win for the open source community as well. Okay, so with this, I'll wrap up my slide portion of the presentation, and I will hand over the floor to Andy. Take it away, Andy.
Okay. Let me share my screen. Can you see my screen, Savita?
Yes, I can see a
Okay,
screen.
cool. So yeah, so Savita gave you a little bit of a high overview of the kind of work that we do in Imply as the QA group, and I am gonna give you a little bit more on the battleground, so to speak, how we test Druid, the kind of approaches that we take to test Druid. So a little bit about myself. I joined Imply as a in 2020. I was the first that they hire. So as you can see, there was a lot of work that was waiting for me to do when I joined Imply. Prior to that, I spent 5 years in another startup company doing similar open source database project. It was called Trophidian. And then before that, I was with HP Compact Tandem slash as you if you know the how the history of the Silicon Valley, that Compact bar Tandem, HP bar Compact. So I always joke that my cubicle never changed, but my email addresses kept changing. So that was a little bit about myself. So today what we are hoping that to talk in this presentation is that we will talk about how we test Druid in Imply. But we hope that you can walk away with an idea of how to test Druid in your own environment, and that's kind of the goal of today's talk. Um, so Druid. Since this is a Druid summit, most people here are familiar with Druid already. Druid is the core of the Imply platform, and this is basically the entire stack that we offer in Imply. You can see that Druid sits right in the middle, Apache Druid. Then on top of that, we have Pivot, which was offered by Imply, which allows you to visualize the data. Then we have the manager layer, which is used by Imply to deploy the entire software stack. Um, on bottom, we have a security part layer. And besides that, we also have a Clarity, which is the DevOps tool. Interesting enough, Clarity also runs on Druid. So basically, we use Druid to power our own software, Clarity, which you can use to diagnose the performance bottlenecks of your own Druid. So you use Druid to diagnose your Druid. Basically, that's how it works. Um, and as most of you know, that Druid is an open source project. It's an Apache software, and we enter incubation in 2018 in February, and then we graduated in December of 2019. So it took about 2 years for us to go through the incubation period, which is not awfully long for a open source project. And this talk, we will mainly focus on talking about testing Druid. We are not talking about testing the rest of the stack in Imply. Um, as you can imagine, testing Druid is a challenging task, mainly because of the complexity of Druid. Druid comes with so many different flavors. Today, Imply offers Imply Cloud, which you run the Druid, say within EC2 instance of an AWS account. Um, and we also offer Imply Private, which you can install Druid on your own hardware that you manage it yourself. And then you probably already heard about this, but Imply SaaS is coming, and that's a new offer that we are working on right now. And that with that, Imply will manage everything for you. So with this kind of complexity and Druid is just so versatile that it adds on to the challenge that we have in terms of testing Druid. So what do we do to test Druid? um, the challenges. Um, and open source, as if you have worked on an open source project before, you know that an open source in general is very strong in unit testing and functional testing. When developers check in their code, generally the code also comes with tests themselves. So that part is pretty solid for an open source project. But what's lacking in an open source project is the end-to-end testing, stress testing, load testing, that kind of testing. And we, as the stats in Imply, we come in and we aim to fill the gap. We are not too overly concerned about functional testing because that's pretty much covered by the development's functional testing already as part of the code development. What we want to do is that we want to see the software from customer viewpoints. We want to use larger data sets. We want to test this in a larger scale, in the real world scenario, so to speak. So having said that, we want to focus on two areas. This being an analytic tool, there were two areas that we are concerned most. One is ingestion. You got to get the data in somehow, and you got to have the data go into Druid in a very smooth fashion and fast enough. The other part of the equation is the queries. Since you need to get the information out, we need to make sure that Druid can return the information in a very timely fashion, and Druid can return the information to you in a correct results, right? We don't want it to tell you the wrong thing. So when it comes to testing, data is the most important part. I mean, this is true in traditional database or in modern analytical tool as well. So where do we get the data from for testing? Um, Nowadays, within Imply QA, we normally use data from three different sources. One is public domain data sets. I will talk about those sources later. Um, One is public domain data sets. There are a lot of data sets out there that you can get already. So that's very convenient. The second source that we normally use is the database benchmark data sets. I'll talk about that later. And then the third source that we use is we have an in-house data generator, which is very important for us as well. So these are the three main sources that we get our test data from. So public domain data sets. A lot of data sets are available to the public. Thanks to our tax money, the government put out a lot of data out there. Anybody can download them. So for example, I can give you two examples. One is like, for example, like a TLC trip. This is from New York State, New York City records of their taxi and limousine commission. That they record all of those cabs that running in New York City. You can imagine the amount of data that's out there. Imagine it starts on from where the taxi picks up the gas, where it drops off the gas, how long it takes, what time this process happened. So there's a lot of data out there that you can download year by year. Depends on how much data you need. The other example is BTS, Bureau of Transportation Statistics, and this focuses more on the flight data. Like every day there were so many flights flying over United States. You can download the data where the flight takes off, where the flight lands, where how long it stays in the air, whether or not it's delayed. This is also arranged by time, so you can also download them year by year. So this is two examples of government data out there that they are public domain, and you can download them to test your software. But there are the advantages and disadvantages of those kind of data. Is one advantage is that the data sets is a lot of them are naturally time series data, right? They are ordered by time, so they are just perfect for Druid's usage because Druid basically is time series database. Um, and those data sets, the other advantage is that they tend to be really large. You can imagine how many taxi drivers out there in New York City. So you can imagine how many flights are there in the sky every day for United States, right? So just 1 year of data, that's huge. And not to mention that you can download decades of data if you need to. Um, but the disadvantages is that the data, you cannot change the data shape or distributions because they are real life data. So whatever data you get, that's what you get. Perfect for large scale testing, but not necessarily can cover all kind of test scenarios that you want to do. Um, so the other kind of data sets that we often use is database benchmark data sets. And if you are familiar with the benchmark world from traditional database, then you probably are familiar with those benchmarks, like for example, TPC benchmarks, like a TPCH, TPCDS, those kind of benchmarks. Everybody have heard of them, or the newer ones like SSB, star schema benchmarks that's kind of branched out from the TPCH. So this kind of traditional database, they often come with queries and they also come with data, which is also nice for testing your software. Uh, Again, advantages and disadvantages. Advantages are if you use them, you know that you can scale them to any scale factor, right? We often refer to TPCH as 100x, 200x, 300x. That x is the scale factor. It's basically how many rows you want, right? Um, so the data is scalable. The advantages is that well, you need to generate them. So you need to you need to find a machine. You need to find a disk large enough to generate the data. And the other problem is that those benchmarks are mostly for relational database because they are kind of old. Most of the benchmarks are pretty old by now. And for Druid, you will have to denormalize them because they are designed for joins, not flat table. So for Druid, you will have to denormalize those data sets first. The other issue is that most of them are designed for AOTP, not OAP. Although in recent years they start to have more and more benchmarks for OAP. However, you still have the same issue that you need to denormalize them. And again, the same disadvantage as the public domain ones is that you cannot change the data shape. You can only change the scale, but you can change the scale factor, but it basically just use the same data shape and scale up or down. It does not change the distribution of the data. That you cannot change. So these are the problems of using those either public domain data or benchmark data. So um, so in order uh, uh, to test the scenarios that we want to test, we come up with the third solution that we use a data generator, in-house data generator. We wrote one. This is a Java-based data generator. Um, this allows us to test precise data shapes and data distributions. It allows us to test corner cases like art, for example, art cardinality, sparse data, skew data, and such. And it allows us to push the boundaries, right? If you have your own data generator, you can test any data size. You can test any number of columns. You can test any number of files. Sky's is the limit. Um, and it's also great for testing customer data shape. Most of the time, if you work for a company, you want to test your customer data, you know the biggest challenge is that the customers are not going to share their data with you, right? Some customer might give you the data, but it requires you to scrub clean their sensitive information. Oh, that's the best situation. But a lot of times they wouldn't even do that. So what we do is that we go to customer and tell them, we are not asking you for your data, but we are asking you to provide us the data shape. For example, the size of the table, what kind of columns you have. You don't even have to give us the column names, just give us the column types. And then, for example, you need to give us the data distributions, for example, the cardinality of each column, min max value of each column, how long your string column is, stuff like that. And when we take that data shape back, we can use this data generator to generate data to simulate that kind of data sets. And that's what we do a lot nowadays to test the real world customer usage of Druid. So data generator, um, you have total control of the data shape. For example, you can tell the data generator what kind of tables you want, file formats, CSV file, TSV file, JSON. If you have used Druid, you know Druid supports a lot of different file formats, which is the beauty of Druid. Um, you can tell the generator how many rows you want to configure. You want to generate a max number of rows, max number of rows per file. How many columns you want, whether or not you want to sort the timestamp column, which is also important for Druid, because when Druid does ingestion, basically the segments are created according to time granularity. primary partition is on time. So whether or not the data is sorted, that this decides a lot about the ingestion performance. So that's important for testing. Um, what kind of columns, you can also configure what kind of columns you want for the data. For example, the column names and types, min-max values for each column, min-max length for string columns. Most importantly, the data distribution, for example, the cardinality or number of unique values of this for each column. Whether or not you allow null values in the data set, which is also important because if you have worked with Druid, you know Druid has two modes. One is SQL compatible mode, and one is SQL non-compatible mode, which deals with null values differently. Um, so that's to test null values is also important. Do you want to generate columns from a set of known values? And this is very useful for generate key columns. For example, if you want to do joins, you want the key columns to have some same values, so your joins actually can produce some results. Otherwise, if you have two sets of completely random columns, random values, then your joins won't come up with anything. That defeats the purpose of testing. So here is an example of spec you can give to the data generator. And this, as you can see, that there's a lot of things that's configurable. And this is a real life spec that we had used to generate a 10 years of unsorted data. I think it's 1 million rows. Um, this is what we use this to reproduce a customer issue, which they ran into OM when they did ingestion. So this was very successful because we couldn't get the data, real data from the customer. So we kind of asked them for the data shape, and they gave us a rough idea of what the data shape looks like, and boom, voila, we was able to reproduce it just with the in-house data generator. And here's the example data. So you can see the first column is always time column, and then the rest of them is according to what your real data columns look like. And this might look like a bunch of human not readable formats, but trust me, Druid can read it because the data generates the data according to Druid's ingestion spec. So with the data generator in place, we are able to do ingestion soak testing. So we implement a set of soak testing to test different data shapes. So for example, we have like event distribution, 100 million rows, 20 years, skew data, uh, various skew data, like 100 million rows in 1 year and 1,000 rows in 9 years, stuff like that. So basically, we are doing a lot of corner test cases with this soak testing. You can test white table, like 500 plus columns. Actually, we can push it even higher to the thousands. Or large ingestion files. One uh, Druid is very good is to ingest multiple files at the same time, right? So larger number of files, we want to push the boundary, and many more. So this ingestion testing and with the data shape and the configuration in the ingestion spec, if you have written a Druid ingestion spec, you know there are so many knobs that we can tune in the ingestion spec. For example, the number of subtasks, secondary partition, do you want to hash single dim? Segment granularity, whether or not you want to override or append the data, reindexing or auto compaction, that kind of stuff. So a lot of those combinations that put together that form our basic ingestion soak testing. And the soak testing nowadays around 2 to 3 days each cycle. So even though each soak testing by default they are more on the functional testing themselves, but if you put them all together and they run for 2 to 3 days, they actually serve as stress testing as well, because we just keep beating this test on Druid for 3 days and see if Druid still stands up. If there's any memory problem, like a memory leak, that would kill Druid in a sense. So having said how we test about ingestion, now let's talk about query. So query, we really, really would like to keep Drew honest. So what keeps us stayed up at night with queries? Basically, performance and resource consumption. Do Druid queries run fast enough? Do Druid query consume a lot of resources like a CPU, memory, and communication bandwidth and stuff like that? So this kind of stuff you can normally address by benchmarking and load testing. But however, the other equation is like, can I trust the Druid query results? Do Druid queries tell the truth, the whole truth, and nothing but the truth? Um, Query connectedness is harder to test, right? Everybody know that a user normally only notice that when the non-record is not seen in the results, right? Or the row sets, the size of the row sets is way off. That's the only way that a person will notice that the query is not returning the right results. So, but query in Druid, it's very complex, mainly because of there were so many factors. Druid support two type of queries. If you are familiar with Druid, you know Druid support native queries and also support SQL query, right? If you come from traditional database background, you come to Druid and you will like, what is that native query, that JSON format query that's so hard to write? But a lot of people actually like it. If you think of it that way, it's like you bypass the SQL part, you just write the query plan and the query plan runs by itself. So that's the beauty of Druid, right? So it gives you the choice of which query you want. Also, as I mentioned before, Druid supports two modes: SQL compatible mode that can be turned on or off, which will treat NUA differently. That it's good for user, but for tester, it's just add another complexity to it. Um, Druid SQL also includes another free software free software called Tsai. We use that as a planner. So this is a free software on free software. That's a lot of free software out there for testing. And Druid queries also can be executed from many ways. It can go from web console, it can go through API, it can go through Avatica, which is JDBC. We support JDBC. We don't support ODBC, but we do support JDBC. Um, so Druid SQL. Druid SQL is a relatively new feature. If you are a long-time Druid user, you know that we only did Druid SQL a couple of years ago. You have a really limited support of joins. You have very limited, we only support left join and inner join with equal uh, um, predicates. It has a very limited support of subqueries. It has because everything had to fit in the memory for now. So the resource there, we put a limit on how many rows you can return by from the subqueries. It has a very limited support of functions. So how do you test Druid SQL with all these limitations? The solution we came up with is a random SQL query generator. So we took an approach to design our SQL query generator. This is based on a KLSI syntax tree nodes, and the user provides a table schema, for example, column names, column types, and the generator traverses the tree randomly to come up with the valid queries. And uh, one thing I want to emphasize is that this is not monkey testing. We are not interested at throwing Druid with all kind of junks and see if it stands up. This is, we want to test queries that they are executable. So the main idea is we want the results back, right? So the queries have to be a valid queries. Um, and you have to comply with Druid's limited SQL support. That's why we did not just take a open source query generator. There are query generators out there, but we normally cannot use them because they would come up with a query that normally would work with other databases, but not necessarily with Druid. And we want to come up with queries that can work with Druid. So with these data generators, you can use parameters to control the query types. For example, if you want joins, you want subqueries, you want aggregations, i.e. you want to use group by, or do you want to use order by? And do order by is also kind of funky because without group by, you can actually only order by the time column. But with group by, you can order any columns. So all these limitations make it interesting to test Druid queries. So when we test the after the generator comes out with a set of queries, we want to do result comparisons. And nowadays we compare the results with another database, such as Postgres. You can compare with any database because they go through JDBC. You can use MySQL as well, but we choose Postgres mostly because it's open source. B, its syntax is closer to Druid. Um, so I said that already. The test driver drives queries through JDBC, and this way we can quickly test thousands of queries each time and come up with queries that yields different results, and then we analyze the result. And interesting enough, a lot of times you also find bugs in Postgres. Sometimes the tool returns the right results, Postgres return the wrong results. But well, since my salary comes from Imply, I'm not going to fix Postgres problem, but I am gonna fix Imply's problem. So here's a picture of how this works. You can see that generated queries. You feed the table schemas, query shape configurations, and then you feed it to test driver. Test drivers drive the JDBC to queries through JDBC to Druid and the Postgres. And the data obviously had to be preloaded. Then we compare the results. And here are the examples of generated queries. As you can see again, these might not be human readable, but trust me, they are valid queries, and they are Druid can run them. And so is Postgres. Postgres must be able to run them. Okay, testing tools. So we use all kinds of tools for testing Druid. For functional testing, we use a unit test. We use JUnit. For low performance testing, it's the usual suspect. We use locust. We use JMeter. Depends on which one is more convenient for the feature or the kind of functionalities that you want to test, or which API you want to drive through. And for integration in CI/CD, nowadays we use Roba framework. And as you can see, that Druid is an open source tool, so we software. So we mostly use open source tools to test this Druid. So it's the best to use open source to test open source, right? Benchmarking Druid. I'm not gonna talk too much about benchmarking Druid, but we did. Someone did SSB benchmark earlier for Druid, and here are some links that you can check out. We got blog posting, and we got videos out there that you can watch if you are interested in this. Also, one of our developers, Jihun, is gonna talk about performance tomorrow. He's really good. If you are interested in identifying the bottlenecks of your performance, go listen to that talk. He's gonna tell you how to analyze the segments allocation and stuff to identify your performance bottleneck. Okay, so the main point of this talk is to replicate the testing experience. So how do you make Druid work for you? As a new Druid user, how do you test Druid in your own environment? Druid is highly configurable. So most of you who have been using Druid for a long time, you know that Druid is not one size fit all. The default configurations are not always the best for everybody. So just do a little bit of functional performance, and the load testing can go a long way in helping you decide how to configure your Druid properly to bring you the optimal Druid experience. So what do? You first decide what kind of data you expect. Prepare simple data sets based on your actual data, right? And then you find out the right ingestion schema. You have to decide which time column you want to use because Druid is a time series database. That's most important. That's the very first thing you have to decide. You want to decide what kind of segment granularity you want to use based on what, based on year, based on day. That you have to kind of decide your segment size because that affects performance a lot. Um, which columns you want to use as dimensions, which one you want to use as metrics. If you have metrics, do you want to use roll-ups? Which helps the query performance tremendously. Do you want to use data sketches to decide on your distinct count? That's what mostly data sketches are for. They all matter for both ingestion and query performance. Then you have to kind of decide your cluster size. What cluster size do you want for current and future workload? And are your queries efficient queries? A lot of times you might have to rewrite your query a better way, whether it be native query or SQL query. You might have to rewrite them for better performance, and that happens quite a lot. Even when we are helping customers, sometimes we will help them to rewrite their queries to achieve better performance. And this is not just for Druid. I mean, for any database, that's always true. So what's next? Next generation Druid is coming. As I already mentioned, that we are offering SaaS. We already have a beta program out there. So this would be, we will manage everything for you for Druid SaaS, Imply SaaS. And however, uh, in with Imply SaaS, you don't even have to do your own testing in your environment anymore, because you won't have your environment. We manage everything for you. So that means what? That means more testing work for us. So that segues to this slide. We are hiring. So if you are interested in joining us for this next journey, come join us. It's fun. You know Druid, you know Druid well, and uh, even after I talk about all the challenges, right? We have enjoyed, but that's part of the fun. And this is a very exciting company to work for, and the people here, you just cannot ask for any better people. So um, if you are interested, check out the career opportunities and come join us. So I think I wrap up just about time, and we have a few minutes left. So if anybody have questions, Savita and I can answer some questions.
I see that there's one question from Scott. Are there any plans to open source the data generator? Okay. Great question. We hadn't thought about it, but maybe, yeah, once we kind of firm up the scripts, it's probably a good idea. We'll do that. So once we do it, we'll let the open source community know.
Yes, that I think that's how Imply normally do things. We gradually will open source a lot of stuff that we
Yeah.
do in house. Yeah.
Any other questions? Yeah, thanks, Ashwin. I saw your comment. Yeah, we will keep you posted. And like I said, uh, I mean, I will be reaching out to the open source community for consideration of moving to the Jenkins framework. So look out for that note. And like Andy mentioned, we are hiring. Come join us. I hope this presentation was interesting enough and motivating for you to come and explore some of the interesting work that we do.
Wonderful. Thank you both for your time. We really appreciate it. And thank you all of those who attended as well. We look forward to seeing you in another session. Have a great day, guys.